Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we'll be solving more examples on combination of above and below the x-axis, finding the area of a curve when we are having a combination of both above and below the x-axis. Please make sure you review the previous video because it's the part 2. In the previous video, I stated the 5 rules and I explained the concept. So I'm going to just solve one more example here so that I will it'll be easy for you to understand. First and foremost, before I proceed, I always say that please don't forget to subscribe, like, and share. Okay. And if you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. So let's go. So let's pick an example now. All right. The example I have here. Number one, we're told to find the total area between the curve y is equal to x cubed and the x-axis. Between x is equal to -3 and x is equal to what? 3. All right, so this is the call for y is equal to x cubed. So we have it like this, like that. With Obi, so like this. Okay, we have this one stretched a bit. So we have this one here. Stretch this curve a bit, somewhere here. All right. So that is that for that. So we're interested between x is equal to 3. So let's assume this part here is 3. And let's assume this part here is -3. So we're interested between x is equal to 3, this part here, and -3, this part here. Okay? And we know that we're finding the area bounded by this curve here and this curve here. Okay, let's assume this is the curve we have. And we're told that this curve is y is equal to x cubed. All right, this is the curve we have here. Okay, so let's start solving. So the first step I told you is that we know that the area must be positive. So step one, we know that the area must be what? Positive. Okay, so the area must be positive. And if it's negative, you have to ignore the negative sign. Now, the second step as well was that I told you as well that you have to break this into smaller what? Area, all right? Smaller area shape. So please, if you've not watched my previous video, please go back and have a look. So that means we can break this now where I can see two shapes. The first one here, which is something like this, okay? We can see something like this. That's the first one we're having. So we're having this shape here. Okay. And we know that this is the origin. So it's going to be between 0 and -3. And the second shape we can see there is this other one here. We're having something like this. And it's between 0 and what? 3. So these are the two shapes we have here. Okay. So these are the two smaller areas that's going to give us the main area that we are looking for. So the next part, step 3. Okay, next part, step 3. What we then have to do is that we then have to break this, integrate this between its respective upper and lower limit. So for this curve here, all right, for this one, it's going to be the upper limit is 0, the lower limit is -3, and it was y is equal to x cubed, right? Now for this one here, the upper limit is going to be what? 3. The lower limit is 0, and it's going to still be what? X cubed. So the next part, step 4, we then have to solve each of them what? Separately. So what I'm going to do, I'm going to solve this one here, 0 and -3 x cubed. Then I'm going to solve this one here. I'm going to solve this one here, which is 3, 0, and what? X cubed. So let's start with this one, the first one. So we're going to have, as usual, you add 1 to the power, then you divide by the new power between 0 and -3, okay? So like I always say, what do? You put in 0 and you subtract where you put -3. So put in 0, gonna give us 0 is equal to 4 divided by 4 minus -3 raised to the power of 4 divided by 4. Then when you put that in, the final answer you will get is -81 divided by 4. And therefore, I told you the area can never be negative. You ignore the negative signs, it's going to be 81 over 4 units squared. Okay? 81 over 4 units squared. Now, the same thing we're going to do for the next one. We're going to integrate this. So when we integrate this, it's going to be x. You add 1 to the power, will give you 4 divided by 4. And you're integrating it between 3 and 0. Okay? So then you substitute 3 minus 1, you substitute 0. And that will be equal to 3 raised to the power of 4 divided by 4 minus 0 raised to the power of 4 divided by 4. Okay? And when you press your calculator for this is going to give you 81 over what? 4. So therefore, the area is going to be what? 81 over 4 units squared. Okay? Then, the next part now, we then have to that step 5. Step 5 is that we then have to solve them individually, okay, by adding them together to give you the total area. Because remember the total area in step 5, I told you that you have to add each of the smaller ones together. So the total area now, let me use another color for this. So the total area will be equal to 81 over 4 plus 81 over 4, and that will give us what? 81 over what? 2 units what? Squared. So that means the area for this is 81 over 2. So similarly, with what we did before, it's exactly the same thing. When you get a curve, okay, you make sure it's positive, you break it down into smaller ones, you integrate it based on its respective limits, you solve it as normal, you get the area. If it's negative, you ignore the negative sign, and you add them together, and that will give you the what? Final area for this. All right. So the next video, I'm going to talk about the area between a curve and an intersecting line. How do you find the area between a curve and an intersecting line? So It's important that you subscribe and you click the notification bell so that when I post new videos, you will be the first person to know. All right. So I'm going to see you soon, and I will talk about this in the next video.